My name is David Panett. We're here at Wilmington Middle School for the 10th anniversary of the Analog Devices sponsored Technology Science Fair. We do that with the cooperation of Chuck Kitchen here, who is a retired engineer from Analog Devices and is also a teacher in residence here at the Wilmington Middle School. We're fortunate to have him on a weekly basis. He comes in and teaches in our science classes. He also supports technology and engineering in those science classes with on-site demonstrations and hands-on demonstrations for the students in the science class. On one day a year, which is happening today, we have our Analog-sponsored Tech Fair, where we have at least 25 engineers from Analog Devices that come in and set up demonstrations in the technology engineering labs here at Wilmington Middle School and provide a very rich and very enriching experience for the students in all of the science classes in the 7th grade. Here's Chuck.
Okay, yeah, and again, this is a lot of fun for us too, because we enjoy doing things with the kids, and these are very hands-on kind of activities, and we enjoy doing them every year. We have some new exhibits this year. In addition to the ones we usually have, we have a one activity or one demonstration, which is a dry ice demonstration, which we haven't had before. Also, another one on super magnets, basically dropping a super magnet into a copper tube and showing that it very slowly drops. It's kind of a very interesting demo, an interesting kind of concept in itself. We also support the other activities we do at the Tech Fair again too, is we have an electricity table where we use battery powered lights and switches and little motors and things that kids like to play with. And we have a magnetism table and a table where we do some sparking demonstrations, which is all quite safe. We also do a number of other different demonstrations, as you've seen, I think, in the videos here in this program, or you will see in the videos in this program. We also have a radioactivity demonstration and a little bit of, it's a very interesting subject and one that becomes more and more important, I think, over time with the things that have happened in Japan and the nuclear power and all of these various other issues that are very important today. So we teach the kids a little bit about radioactivity and nuclear power and some of these issues with those things.
We also have a demonstration on integrated circuits and how they're made, strobe light demonstration and how that actually stops the droplets of water in a stream of water. And we teaching the kids how to solder and giving them a demonstration how to solder, and also a laptop computer that's all expanded and showing the different component parts of the laptop computer and how they come together to make a computer, which all of these students are definitely familiar with. Again, it's a rich and a rewarding experience for the students here at Wilmington Middle School, and we're very thankful to have Chuck and all of the other folks from Analog Device here to provide that for the students here at our school.
Oh, I'd also like to say in closing that we're also very grateful, we should all be very grateful for people like Dave and the other teachers that come in here day after day after day to educate the children of Wilmington. So they're all superheroes in my opinion.
There's all the bits here, but if you have a look at what the guts of this thing really is, you're going to see a whole bunch of these integrated circuits. See these little black? There are all different kinds of integrated circuits on that hard drive. Definitely. So, we're going to talk about how we make microchips at Analog Devices.
So you take the soldering iron and stick it in the loop against the two metals, the wire and the loop. So now against those two, now take a little bit of solder right here with the other hand and put it against those two, that joint of those two metals, and it will melt.
So what happens is every time a drop of water passes that point, the strobe light is flashing and you get to see it. Well, the problem with the video is you've got this light flashing 60 times a second, and if the video is flat, so the video is taking individual pictures too. The impression that it's in slow motion. So if I flash it at just the right drop, roll in.
What do you think you could do this? Could you make a band controller out of this?
It's either B or D.
Like a few volts, every 2 volts, or 5 volts. If you could find the rip the electrons right off. This finger. We only got 15,000. Then you get 2 separate. And one finger could.
You want to straighten it out, you can get inside. I'm screwing your head off. I like your pink hammer. Thank you. It's very manly.
Oh, that battery.
If you want. Thank you very much.
Sometimes I really see it.
It doesn't stick to the copper. If I drop the magnet through the copper pipe, and that current makes a magnetic field that goes in, push it back on the magnet. So it's making its own field that pushes back on it. And the gravity pulls it down, and it goes very slow. So if this was a superconductor, it wouldn't go at all. It couldn't.
This is dry ice. This is regular ice, dry ice. And it's called dry ice because it doesn't form a liquid at room temperature like water does. Dry ice, which is carbon dioxide, solid carbon dioxide, sublimates. So it goes from solid to gas, skipping the liquid phase. It has no liquid phase at 1 atmosphere. So dry ice is very, very cold. Very cold. It makes a sound when I touch it is because this is very, very hot compared to the dry ice. So, and the carbon dioxide. But if I put something basic in it, you see different colors. So that's it's a little off pH neutral, and then the carbonic acid will overcome that.
I made it through the wilderness. You know I made it through. Didn't know how I Oh my God, all the people!
Analog rock. Stand still, back off.
All right, so we're gonna, okay, this is a regular nail, a plain iron nail, and we're gonna put a lot of electricity through it, and it's gonna get real hot, and it's gonna melt. And iron melts at about 2,800 degrees, so that's smoking hot.
2,800.
Okay, so don't put your finger there. Okay, let's have a countdown from 5.
Put a countdown. 5, 4, 3, 2, 1,
Okay,
go!
And
I don't see anything.
all right, is it?
Oh, look. Starting to
Changing,
smoke.
it's smoking.
Now it's getting red hot.
Whoa, baby! Oh, this is a nice
Oh,
one.
look at that.
You're right.
Oh,
Whoa. Melted apart.
there it is.
Why is it still saying so red?
Oh, man.
I'm measuring the amount of milligrams per hour of beta and gamma waves coming out. Beta particles and gamma waves. Radioactivity. Measuring radioactivity.
Negative, red one goes to positive. So measure one of these and see if you get a volt and a half. Volt and a half, 1.5 volt. It's a little bit high.
You have to say, we have questions to say.
This negative and that positive.
But I'm HR.
Anyway, with
don't connect it there. We're going to measure it.
Oh.
If you connected it, you'd short all of the batteries together and they'd melt.
Is red positive?
Yes, red to positive. All right, so what do we get?
4.68.
4.68.
I love this stuff.
So we all really appreciate Analog Devices coming down and showing us experiences that we don't usually have in school, especially with the tech fair.
It's really cool how they introduce it to us at such a young age, because then when we're older, we might have an idea of what we want to do for a job or a living.
Well, I really appreciate it because it helps kids learn about technology and stuff, and you don't usually get to do this in school, so yeah.
I think we all want to thank them most of all for taking time out of their busy lives just to come down here and help us out and show us what Analog Devices do and give us an idea of what we want to do when we get older.
Analog rocks!